Hello, everyone. Thanks for joining. I'm Niklas from CrateDB, and I want to guide you through an example today of how to use CrateDB with PyCaret. So to take a brief look at the scenario, we will explore in a bit more interactive way shortly. Our starting point is that we have machine data here on the left, more specifically temperature data that we are getting from the machine. And we want to use CrateDB as a central database solution, and then explore and analyze the data in an interactive way using a Jupyter notebook here. And then on top, we don't just want to work with the raw data, but we also want to apply machine learning on it. That's what we are going to use PyCaret here, which you can see at the top, for computing anomaly detection. And we want to do it in a way that it's really integrated with the data, so that the anomaly data doesn't sit separate in the Python world, but that we really write it back into the database and can integrate it into our analytics that we do here on the user side. So that being said, let's get practical and switch over to a Jupyter notebook here, where we will run a couple of Python commands to really go step by step through the process of how to get to that end-to-end integrated use case. We're starting off by installing a couple of requirements here on the Python side. We will touch on the more significant ones in more detail as we get to it. But for now, we just need to get the environment ready to get started. And then we import here now a couple of libraries that we just installed into our Python runtime environment. Now, to get started with the use case, with the machine data that we just saw, that the temperature data, here we are now going to connect to CrateDB. So you would see a couple of SQL commands here, which are the most important ones to focus on. The rest of the code that you see here is really more or less just the logic around sending those statements to the database. So we are starting off by creating a table, and you see here it's standard plain SQL in a schema called anomaly. We're creating a table called machine data, and it has two columns, timestamp and value, pretty straightforward, where the value column is going to store our temperature data. And then for this demo, we are just going to do a one-off import where we use CrateDB's copy from command, where we take a CSV file that's publicly available on GitHub and just load it into the table. So let's run this. And in the meantime, while data is importing, switch over to CrateDB. So we are working here on a 3-node distributed CrateDB cluster running in the cloud. And this is our admin UI, which you can use for exploring the data and getting an overview of what's happening in the database. And if we switch now here to tables, we will see that table definition that we just looked at in the anomaly schema. There is a machine data table with the two columns, and we can click query table here. You see again, just a standard SQL select query. We're working with the data, we can query the data, and we will see exactly that type of data here with the timestamp and the value, which is our temperature reading. So far, so good. So we have now our raw data imported into the database. Now let's move a bit further into the direction of our machine learning model. So we want to do anomaly detection. And in many of the cases that we see, one of the issues here is that the starting point, our raw data, is often of very high frequency. So there are many rows, maybe you sample the data at a second interval or even more frequently. So a common task first is to reduce a bit the data volume that we want to load into the machine learning model. And a common approach here is to use a select statement with the dateBin function, where we can resample the data, in our case here into 5 minutes intervals, where we just apply a standard aggregation function. Like here we take the average value. We could also take the minimum, the maximum, quite some flexibility here, but to keep it simple, we take just the average here over the last 5 minutes. And for now, we just load it into our Python runtime environment here. So we use a pandas data frame. Let's execute the statement here. And you would see that is pretty much just a representation of exactly what we saw in the raw table in the CrateDB admin UI. But if you take a closer look at the timestamp here, then you would see it's now grouped in 5-minute intervals, then with the average value instead of returning each and every raw reading. Now, maybe a bit hard to imagine how exactly that looks like. So let's use a library here in Python to just plot that data, see what it looks like, to also get a bit of a feeling where there might be anomalies. And when looking at the data, I think there are 2 timeframes which stick out a bit. So there is that one drop here where the temperature goes down almost to 0, which might have been maintenance work. It might have been an outage. We don't know for sure, but apparently something out of the ordinary happened here. Then going forward, that looks all pretty much at the same range. Maybe here, then February 9th, another occasion where maybe there was data missing or data also dropped due to some unexpected event, but that might also look a bit suspicious. So for really analyzing the data without these anomalies, our approach is now we want to find a way how to remove those anomalies and do data cleansing in a certain way to really show the regular data points that are not anomalies. And to do this, we are using PyCaret. So PyCaret is a very powerful Python library, which is a wrapper, an orchestration library, you could say, around many different machine learning models. So we take our data frame here, the data that we extracted from CrateDB, and set up a PyCaret instance. And the models function that we call here lists us all the different models that are possible to apply here on our raw data. And you can see there are quite a few different models available. We will not go too much into detail here around which is the best to choose. That is a whole different topic on its own. But we are going to use MCD, which is the minimum covariance determinant model here. But basically, you can also use other models. Which one is the best for you really depends on the raw data that you're working with. But for our case, we just tell PyCaret now that this is the model that we want to use. Depending on the model, there might be a couple of parameters that you can use to tweak and fine-tune the model. And now we are going to train the model and basically filter out only the data where the model is sure that it has detected an anomaly. So where that value here is 1. And if we look back at the result that the model now returns is basically the timestamp with the average value that we calculated before in the select statement. Now we filtered only for those rows where anomaly equals 1, so where the model has detected an anomaly, and we get a more fine granular anomaly score here as well if we want to further sort by checking how sure the model really was that a certain timestamp is an anomaly. Now let's plot the data again and annotate it with the detected anomalies. And we see exactly this drop that already looked a bit suspicious to us initially has been detected. Those are the red dots here that the model has added to the graph. So here the model thinks it's an anomaly. We see a couple of more data points here at the lower end of the range, and then again here also that drop around the February 9th data points. So this is now where the model thinks probably there is something wrong with the data that looks like an anomaly. And we have that information now here in our Python runtime environment in our Jupyter notebook. But ideally, we want to bring it into the database as well. So if users are accessing the data through any other drivers, through any other tool, that they also can make use of the data and it doesn't just sit here in memory for us on our workstation. So therefore, the next step, what we do here is we create another table in our CrateDB cluster for those outliers, we call them, which is again just a standard SQL statement. And then we use our outlier dates. So this is the data structure that holds the information from the machine learning model on the timestamps. And there is a very handy toSQL function here in Python pandas data frames where we just tell it to store that data in that table that we create before and append the data into that table. So if we run this and switch back to our CrateDB database, then we see there is a second table here for our outliers, just the timestamp column. We can query it again, standard SQL, and we see the timestamps of those 5-minute intervals that the model has flagged as being an outlier or an anomaly. Okay, and now we already made the circle back into the database. And now we also want to remove the data from that query that we saw later on, or before actually at the beginning of our session. So if we imagine there might be a dashboard where users in the whole company look at the latest data, where they do exactly this also type of date binning, aggregating by 5-minute intervals. Now we extend that query a bit to have here a common table expression at the top where we select from our original machine data table, then we do a left join on our outlier table. So we basically check, is there another row that matches? And if there isn't, then great. We know there is no outlier. We can keep the data. If it's not null, then we want to remove that data point because it has been flagged as being an outlier. And then we calculate the exact same date bin and average calculation on top of the data again. And if we run this, so far so good, looks exactly the same structure-wise as our previous original raw data, still 5-minute intervals with an average value. But if we now plot those two data frames, and we have here DF, that is the original data frame that we calculated using all the raw data without excluding the outliers. And now we have the cleaned data frame, which is the one where we just looked at the SQL query that excludes the outliers. So if we tell Python to plot our data or two data frames here, then maybe at a first glance, it doesn't even look too different. But if we take a closer look at the drop here, the first one, which went in the raw data all the way down to almost 0, and take a closer look here now at our cleaned data, then we see actually those low values have been cut off. They've been identified as outliers and removed. And it drops only towards 48 degree here as a temperature. and everything below, which we see here, the original data, has been removed. So the whole range in which the data moves is now more smooth. We see here the lowest value is around 50 overall instead of going down to 0. And that also shows here in our second anomaly later on in the data, where we see looks a bit more smooth. It still shows there was something going on. There was a sharp drop, and maybe there have been a couple of missing readings here, but it has removed some of the noise, so it didn't alter the complete meaning, the interpretation of the data, but those data points which appear to be outliers have been removed. And how well that works obviously depends a bit on the quality of the data model, and can definitely be fine-tuned a bit further. But what we wanted to show here in this quite short demo is how you can basically use the same database, being a CrateDB here, to store both your time series, your raw data, as well as your machine learning generated data, the outliers in this case, feed it back into the same database engine, and then have a end-to-end result where users can leverage data from both of these different data types, data sources, and do not need to get data from different systems and join them, but all is in one place so that you can have a single source of truth. And that already concludes our quick demo. I hope you enjoyed it. Please feel free to drop us a message at our virtual booth if you would like to know more. And then I would say thank you for joining today.